Hello friends, welcome back to our channel. So in today's session we'll discuss about one more concept in discrete mathematics, that is introduction to recurrence relations. So in our previous session we have discussed about the principle of inclusion and exclusion problems, and now without delay we'll start the today's session, recurrence relations, the most important concept. So in this session, we'll discuss about what exactly the recurrence relation means, and we'll see some applications and one example for this recurrence relation. And further in our next sessions, we'll see what are the different types of recurrence relations and the problems related to the recurrence relations. So what is the recurrence relation? So we all know the example of, we all know the problem of Fibonacci series, right? So Fibonacci series. Fibonacci sequence or a series, anything. Okay, so what is a Fibonacci sequence? So the the current value will be the addition of previous two values. So a current term will be addition of previous two terms. So we know the sequence. It will start with 0, 1, 1, 2, 3, 5, 8, 13 and so on. See, here the initial values will be there. So initial values are 0, 1. And from the third term, we have to add the previous two terms. Okay, so that means the current term depending upon the previous terms. Okay, so what we are doing? Addition. Okay, we are adding the previous two terms to get the current term. So that means we can say the current term can be a function applied on two terms, two previous terms. So that we call it as a Fibonacci sequence, and it can be written as, so f of n is equal to f of n minus 1 plus f of n minus 2. So this is the formula to find out the any term in the sequence, and this is the best example for the recurrence relation. So a recurrence relation is to find the terms in a sequence in a recursive manner, is called as a recursive relation. Okay, I am writing the definition here. So relation that finds terms in a sequence in recursive manner. In recursive manner is called recurrence relation. Okay, so particularly if there is any sequence or a series, the current term depends upon the previous terms. So the same thing we call it as a recurrence relation. So a relation that finds the terms in a sequence in a recursive manner is called as a recursive relation. And this recursive relation is also called as difference equation. Difference equation. So the best example for the recurrence relation is the Fibonacci series. So we are applying some functionality between two previous terms. So 2, how we are getting 1 means 0 plus 1, and how we are getting 2 means 1 plus 1, 3 means 1 plus 2, so like that and so on. That means we are adding the previous two numbers. So similar to our Fibonacci series, there is a one more example called Lucas series or Lucas problem or Lucas sequence. Okay, see one thing before going to the Lucas sequence. See here, coming to the current term, Fn will be the current term which depends upon the previous two terms. right? Yes. So for every sequence, we'll be having some initial values for any sequence. For example, if you take the Fibonacci sequence, the initial values, we can start with A0, A0 will be 0, and A1 will be 1, and from A2 we will be connecting with A0 plus A1. Okay, so how we are getting A2 means by adding the previous two terms. So there will be initial values for any kind of sequence. So with the help of the initial values, we are finding out the next terms in the sequence. So this is an example for recurrence relation, and one more example I'll tell you for this recurrence relation, that is a Lucas sequence or Lucas problem. Just now we have seen. So Lucas sequence. So what is this Lucas sequence? Okay, so it will start with 1 and 3, and the same function which we have applied in the Fibonacci applied for the Lucas also, but the initial values are different here, 1 and 3. So the next term will be addition of previous two terms, 4, 7, 11, 18, 29, and so on. So here the function is also similar. F of n is equal to f of n minus 1 plus f of n minus 2. Okay, with initial values, that is most important. With initial values, a0 is equal to 1 and a1 is equal to 3. So this is called a Lucas sequence. One more example for recurrence relation. So any kind of relation which finds the current term depending upon the previous terms is called as a recurrence relation. Now what are the applications? What are the different applications where we can use this recurrence relation? A simple topic. So applications of recurrence relations means the first one majorly we will use these recurrence relations in the algorithm analysis. Algorithm analysis. Okay, that too particularly in divide and conquer algorithms. So any kind of problem can be solved by using some algorithms. So there will be a different algorithmic approaches. So in that, one algorithmic approach is a divide and conquer. Particularly for this algorithmic analysis, in order to find the time complexity, we are going to use these recurrence relations. And the second one, counting problems. Counting problems. And the third one, we all know, sequence and series. Sequence and series. So we are supposed to, we'll be writing a different examination. So in that we are expecting a question in this particular sequence and series. We need to find the next term following the particular sequence, right? In such case also we are going to use the recurrence relation, because the next term will be calculated with the help of the functionality applied for the previous two terms. So these are the few applications of recurrence relations, and there are a lot of different types of recurrence relations. So in our next session, I'll focus on different types of recurrence relations with a clear example. So this is a most important topic, that is a recurrence relations, right? So hope you understood, and now you got an idea about what exactly means the recurrence relation. And I'll close here. And if you really enjoyed my session, like my session, share my session with your friends, and don't forget to subscribe to our channel. Thanks for watching. Thank you very much.